United States is subjected to some of the world's most diversified weather conditions. During the course of a normal year, our country may experience plus 100 degrees temperatures, jungle humidity, negative 30 degrees cold, severe drought conditions, as well as being the world leader in tornado activity, not to mention an occasional East Coast hurricane. As our transportation system has expanded, so too has our tendency to commute on a daily basis, to work and recreational events. The potential for weather to complicate our lives has therefore also increased. Aviation, perhaps more than other readily available mode of transportation today, is strongly impacted by weather conditions. Did you know that 75% of all airport delays are related to weather? In 1996, the estimated price tag for weather-related delays, diversions, cancellations, and unexpected operating costs was $2.1 billion. The U.S. government invested approximately $830 million in aviation weather efforts during 1997. As the magnitude of these numbers indicate, ensuring weather-related safety and efficiency of flight has economic and human life ramifications to business and traveling public communities. Weather has a continual impact on both the safety of aircraft in flight and the efficiency of operations throughout the National Airspace System. To complicate things even more, air traffic is projected to triple over the next 20 years. More planes and people in the air flying longer distances more often. Imagine what a weather delay will mean with more air traffic. Talk about a traffic jam. How important is weather information to your daily activities? How well do you understand the weather system and the interaction of the various elements on the daily forecast? But most of all, how might weather in one location affect your planned travel to a different region? Today's meteorologists have the tools and advanced technology to explain complex weather phenomena in a way that's simple to understand, thanks largely to satellite information and computer-based modeling. Dennis Smith of the Weather Channel in Atlanta, Georgia, has offered to explain and help us understand the fundamentals of weather. Dennis?
Thanks, Van. As many of you know, the Weather Channel provides 24-hour weather information both from a national and international perspective. Our meteorologists constantly monitor and update weather information. Now today we're going to fly through some basic weather concepts and talk a little bit about winter weather, which can cause some problems for aircraft. To explain how our weather occurs, we must first travel out past the boundaries of our atmosphere, 93 million miles away. Our sun emits visible and invisible energy that we call solar radiation. Radiation from the sun travels through the Earth's atmosphere, heating the air, the land, and the water it contacts. The Earth's surface absorbs much more radiation than the atmosphere. This means that the sun heats the ground and the ground heats the atmosphere. Not all parts of the Earth are warmed equally. Regions around the equator receive more concentrated solar radiation than do areas around the poles. The result is that the equator is warmer than the poles. Temperature differences also result because land and water do not absorb solar radiation equally. Because air moves, warm air and cold air are constantly mixing in the atmosphere. This mixing not only evens out the global temperature contrast, but results in the various weather conditions we see every day. If solar radiation penetrates all layers of the atmosphere, then why does nearly all weather occur in the lowest layer, the troposphere? The troposphere is warmest near the ground and cooler the higher you go. This temperature pattern is favorable for the development of vertical air currents. Relatively warm air tends to rise, and relatively cool air tends to sink. As warm air rises in the atmosphere, it expands and cools. As air cools, clouds can form, and precipitation can fall. Warm air rising causes less pressure to be exerted by the atmosphere, lower air pressure. Cool air falling causes more pressure to be exerted, high air pressure. As warm and cool air flow from one region to another, pressure changes, and so can the weather. When air pressure falls quickly, it usually means that stormy weather is approaching. That's the result of a low pressure system. When air pressure rises, fair weather typically results. That's the result of a high pressure system. Wind is another byproduct of changing air pressure. Winds flow because of the pressure differences in the atmosphere. Air moves from the areas of high pressure to areas of low pressure. Winds spiral inward toward low pressure, causing a piling up of air, forcing air to rise and cool, forming clouds and eventually precipitation. Around high pressure, winds spiral outward, promoting sinking air, and fair weather.
Okay, now, while you're soaking up that information, let's think of something a little bit more fun. Snow days.
When you think of winter, is this the picture you see? Snow, snow, and more snow. But there are other types of winter precipitation. The type of precipitation that falls during winter depends on how warm air moves over a layer of below freezing air. A good place to start is with sleet. Sleet is frozen precipitation falling as ice pellets. These ice pellets form when snowflakes pass through a thin layer of warm air and melt. They refreeze into ice pellets as they fall through another layer of colder air close to the ground. Freezing rain is made of water droplets that fall to the Earth's surface and freeze upon contact with the ground or objects near the ground. For freezing rain to develop, cold air close to the ground needs to be shallow. The rain doesn't have time to freeze into ice pellets, but upon contact with frozen objects, it turns into ice. Snow is frozen precipitation in the form of a six-sided ice crystal. Snow is produced in clouds where water vapor changes directly into ice crystals that remain frozen as they fall to Earth. Snow will fall when temperatures remain below freezing from the clouds to the ground, or when a very shallow layer of above freezing air is present near the ground. Winter weather can be a lot of fun to play in, but it can cause some problems for us when we try to get out and travel, either by foot, by car, and especially by air.
Now that you have a better understanding of weather, here's a question for you. Weather reports of snow are typically based on visibility. Snowfall is considered heavy when an observer cannot see very far through the flakes. But visibility is not the critical element for the meteorologist interested in aircraft operations. What do you suppose is the main issue that is considered in looking at snowfall from the perspective of aviation? Back to you, Van.